Today we're on job number 21. It's another Maxcom 4E, and we've had quite a few coming in recently. Let's see what he says. Now, we already tried his microphone and we found the insert to be open circuit, so he's going to be, we'll do him a new microphone. This is our Comtron test mic, and that should work with the Maxcom. Don't necessarily work the other way around because there's an extra link in the Comtron one. So original microphone, fused power lead, which we supply. So there's no audio transmitter, not even in PA mode, of course, which is because the insert received audio on the internal speaker. Yep. He thinks it's a failed element, which is absolutely right. Good. Right. So we'll do the usual. In fact, I think we'll make the notes on the back of his letter. That's latched okay. So we'll connect it up to our ridiculous crocodile clips. He's powered it up, so we'll go straight for 13.8 volts at 1.6 amps. I don't need to pussyfoot around because we already know the radio isn't going to be short circuit. So we'll connect that to our test equipment, and we'll connect that to our test equipment, and we'll connect the PA speaker in line with latest company policy, also like that. I don't know how many of you have seen the Maxcom Super 4E with its green display. Right, so I'll put picture in picture on. Right, here we go. So we'll start off on the 3-watt scale. Oh, it's still in PA mode, is it? Testing 1 2 3 4 5. 1 2 1 2. That's interesting. Have I got them the wrong way around? No, I haven't. Comes out of both. Testing 1 2. Okay. Right, we'll disconnect that for now. Testing 1 2 3 4 5 5 4 3 2 1. So that's coming out of there. Wanted to prove that. It comes out of both when you've got extension speaker connected as well. That's daft and undesirable. Right, into transmit. It's got the TX light working. It's doing 3 watts. Let's just change scales. On that scale it says 2.9 watts. So Maxcom 4E TX 2.9 watts. Deviation wallow is 1.8 to 2.1 kilohertz. So that we need to bring that up. We'll do a frequency check, but the test set's only just been switched on, so we'll take that with a pinch of salt when I find the right camera. So it's 2779085, which isn't out of spec, but we'll bring it up. But a bit later on in the video. I'm going to out doing Mrs. Stingy's shopping this morning, so we'll do a bit of this and then come back to it. So let's look at receive. So if we set the signal generator for something similar, it would be disingenuous, wouldn't it, to have the signal generator on spot on frequency when we know the radio isn't. 790 007, that's with James Bond's frequency. So we'll go a bit higher because that's going to be about where we are. Okay. And we can straight away hear the signal generator. So go to the SINAD meter, which is already reading. Yeah, we should get better than that. So it's... I'll show you on the attenuator where we are. So we're on 3 microvolts. So on the bottom scale, actually we should be able to read lower down. Change scales. Yeah, we can. So we're now on the 1 microvolt scale, and it's 0.88. Which is okay, but we hope we can improve it. So it is low on power, about as low as new sets when they come out of the factory. Except the new sets don't seem to adjust very much. Right, I'll get it opened up. Always liked, we'll go to talk about microphones again, and I'm not a coffin mic lover, but it's all I can get at the moment with a real lead on it. So the mics I prefer are these, and I'm now down to about 5 in stock, so I think we sold them at $14.99. And unlike other people, we don't change the price when they become scarce. But we're now on the coffin mics, which is the same price. Right. It still smells of... I don't think we're going to have to disconnect the speaker today. It still smells of Maxcom newish radio, but it also smells of nicotine. So, seeing as I've got the Comtron instructions handy, we may as well use the notes for that. Right, we'll go back to transmit and go on to that main display. See if we can bring the transmit power up. Out of interest, to see where low power is. 0.3. We don't need to be checking the VCO on this. The radio's never been messed with. The wax is still sealed in the VCO. You know, it's only when you don't, some sets, like the Amstrad type chassis, the PTBM002F Cybernet economy chassis used in those, and the Harvard 402s, and a plethora of other sets, including the Mustangs. Yes, always check the VCO. The Cybernet 134s, to some extent, but on these, most of the time, the components to check the VCO aren't even fitted. So theoretically, you'd have to fit about 3 or 4 parts to be able to successfully check the VCO. So I don't need to prod around on that. So we'll go straight into transmit, and on this scale, that's dropped quite dramatically. Oh, we're on the 30 watt scale, aren't we? So I'll stay on the 3 watt scale till we get to full scale deflection, because it's easier to see the small changes like we had with that there. definitely got all these to peak. So now we'll move on to the other ones. So now we're off that scale. We're now at 4.1, 4.2 watts, that kind of area. So we'll just see how it will actually go to about 4.2. So we'll set it to a careful 4.0. Excellent. So now on low power, we'll go to the other scale. It's doing 320 milliwatts, and as I remember it, it's not adjustable. I can't honestly say I can see the low power switch on the circuit. Probably isn't there. So we want the meter on the front to read 4 on the scale. It's banging across. So remember, it's only going to read into a dummy load. You can't adjust that onto an aerial. And there's a dummy load, of course, in the test instrument which I'm using. So deviation is the next one down. So we'll get the little oscillator out, wherever it's going to walk to. It's going to walk to there. So it needs to come up a fraction. Wallow, 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 wallow. Hey, that's it. Done in one for once. So that's now 2.2 to 2.5. So it's 2.2 average, with absolute peak of 2.5. Out of interest, let's see where the power is on the other channels. It's not really adjustable on these sets, but it would be just interesting to see. So on channel 1 it's 4.05. On channel 40 it's 3.95. And of course it's 4 on channel 20. Right. I'm going to bring the frequency up. I mean, we've been 20 minutes with the test set on. It needs to be a bit longer, but I'll check it again when I come back from Mrs. Thingy's shopping. It's pretty well the same, so we'll just adjust that so that if we can get it on frequency exactly. That's down. Oh, it's coming. So just slightly overshot that on purpose, because of course, as you know, they drop with age. Right, let's have a look at receive. So we'll go to the oscilloscope first. We'll start by switching the oscilloscope on. I'm going to put an S9 equivalent signal on the signal generator of 100 microvolts. And what we're doing here is to check that the detector, so put a meaningful amount of volume so I get a proper trace. The detector coil, which is vulnerable to going out on this chassis, check its peak. You know, it was pretty well spot on. That will make no difference, which is actually noticeable, which is great. So we'll take this oscilloscope off, put the bench light back on, go to the SINAD meter. I'm going to have to put the air conditioning on in this room. It's supposed to be cooler today, but I'm in shorts and a t-shirt and it's still far too hot. No distress capacitors. I've only ever changed a couple in any of these sets ever. And when I say these sets, I mean anything with this chassis, including the Midland Precision series. Right, let's start at the front end. So as ever, we're going to turn the attenuator on the signal generator so we get about 4 dBs on the SINAD meter. You see that's worse. So it's about, there's no difference there. Worse. Worse. Next one. Worse. Worse. So that's the peak. Next one. And then finally, just put more signal on that one. I've got to knock the thing off frequency now. There's a dry joint somewhere. Oh, we've got a duff coil. There's that one. Look how that's changing. Right, I'll pause the video and we'll open the setup. Right, that's the bottom off. So let's just see if we can, wrong camera. See whether we can zoom in. So that's potentially dry joint. See where that coil is. It's this one down here. Trouble is, now I've poked and prodded it, I can't make it go off. There are one or two potential dry joints. And it's just about. It's not because it wasn't soldered properly. It wasn't that the components weren't cleaned properly 40 years ago. We'll turn it off. So I'll go over this with isopropyl alcohol later. That one. Sometimes they really do need to be unsoldered and cleaned and resoldered, but I think the flux will be adequate. Just having a quick look for anything potential. So that's all the potential ones I can see. So I'll put the lid back on loosely. Run through these two coils again. Nothing's moving now. Right, we'll read off a new SINAD. So it's just under 0.7. So, you know, he's gained an extra 100 yards range there. Should get scratchy corner. Good, that's nice and stable. S meter. So it should be S9 at that point. So we'll put 100 microvolts once again on the signal generator. It's reading S6. So we'll just see if this one's got a preset for it. Sometimes it's on the meter, sometimes it's on the board, sometimes there isn't one at all. I think it's there on this one. No, it isn't. Is that low power then? Let's go back to transmit. Yes, it is. Good, we can get low power to spot on 400 milliwatts. So I'll go back to that camera so you can see that now. So on low power, there's half a watt. And then back to the full scale power on the 30 watt range. Again, that's now 5 watts. And it's cold, it's 4.1. Good. But it doesn't solve the case of the missing meter preset, does it? And this may be a case that it doesn't have one. So take the bottom off again. I like taking the bottom off, obviously. So sometimes there's a preset on there. You can have 3 sets you think are the same and they're different. And that one, I think it's wonderful. Notice it's not adjustable on this set, so it's an early version, which is not that early because it's January 1982. So we know we've got transmit meter, we've got deviation, we've got low power, and we've got squelch. and that is it. So it's what you'd call a lazy meter. So let's see what S9 is. It's actually 300, it's a bit more than 300 microvolts. It is, what scale am I on? Top one. It's actually 500 microvolts. And no, we don't fit presets when they're not fitted. That's how it was manufactured. Right, so lazy meters aside, S9 equals 500 microvolts, exclamation mark. Yeah, S meter when fitted, it's RV104. See, this doesn't show the preset for low power. Fascinating. Squelch. So we're going to set the squelch now to do this all on the attenuator controls. Set the squelch to full, and I want the squelch to open with a 100 microvolt signal. It's not opening. It's opening at 1 millivolt. So that's a bit too vicious, so we'll drop that. Well, we'll drop it if we can. So it's just not quite opening at 100 microvolts. Let's go, I'll tell you exactly where it does open. That's 100. It's actually 220 microvolts it opens. So that's the most sensitive we can set it. But at least it does open, because on some sets, I'm not saying about Maxcoms, but on some makes of set it never ever opens at full squelch, which is absolutely ridiculous. So we'll go to the opposite end, we'll switch the signal generator to standby and park it at 0.3 of a microvolt. We'll turn the squelch on the radio to threshold, switch the signal generator back on, and see at what point the signal generator comes through. So I said we're at 0.3, that's 1 microvolt, it's come straight in. So let's get an accurate reading. It's coming in at 0.45 of a microvolt, and it's going out at 0.4 of a microvolt. So very nice sensitive squelch. So that had to be adjusted. So I think we're there. I'm going to make a mic up before putting the radio together, and then we'll check that it actually is the same performance as this one, because I hate it to be a different deviation to what I've set it to. So we'll pause the video, I'll go and do that shopping job, and we'll make a mic on my return. Right, so to conclude, I've now done a mic for this, so it's the same as the one I was using, and when I looked at the circuit diagram, it also has the link like the Comtron, so I've wired it just like the Comtron one. So that's into our monitor receiver, testing 1, 2. So that's that. There's just so little choice over mics at the moment. What do we do next? Yes, well, the receive is now, it's been on all day, it's now 4 o'clock in the afternoon, and it's 7.76 microvolts for 12 decibels SINAD. It was 0.79, so as it's warmed up, it's come a little bit better. Transmit is still doing 4 watts, and we'll just check the frequency for a final thing. It's a little bit high now, everything's warmed up. There we go, that'll do nicely. So it's just really a matter of putting the case back on and making sure the internal speaker works. I don't think we've time for any CBs tomorrow. So this was box 21, so whoever sent in box 22, you'll be next. We've got a couple of new things we want to push in. Another version of this handheld, it's the PNI version. Right, we'll unplug the test equipment. Yes, the internal speaker sounds fine. As ever, I'm trying to put the lid on the wrong way. It's a nice condition set, this. So it looks like the biggest snag with it really was the dry joints. So the receive was intermittent in the way it performed. So it was always going to be receiving, but it would be changing the way it received because of this. 1 minute it'd be 1 microvolt to receive, the next it'd be 3 microvolts to receive. So we'll try and do that. I don't charge anything for dry joints, except on Shoguns, which we don't service anyway. You're just never sure whether you've hit them. You can only do the experience thing, can't you? And we do have the video microscope on the other bench, just in case. I think we're using the screwdriver on this set. Seems to have attracted bits of metal. We've got another of those Midland emergency sets come in. Is it the 77810? Complete with its mag mount. And we've got a PE Ranger. Now, before CB was quite legal in 1981, Practical Electronics ran a project to build a half-watt 6-channel crystal controlled transceiver called the PE, for Practical Electronics Ranger, and this was also available as a kit. Obviously, you could buy it you could build it as a project. We've shown one of these before because I've got one, and I've got an unbuilt kit as well, and I've got an unbuilt base station adapter, which turns it into 4 watts with an S meter. And this was a transportable, and I think we did quite well on the range despite the half-watt. Anyway, we've got one of those. It's the Autumn Products Ready Assembled version, I think. And that'll be coming in. But the first thing we'll do to it is evaluate it, because I'm going to have to order battery holders for it. So we'll do an evaluation when it gets to its turn, get the battery holders, and then we'll do the full thing later. Right, so I'll turn the soldering iron off. You know, I don't like the sound of that crackle. Is this speaker rubbing? Just plug into our extension speaker. We'll find out on the air test, unless we find some good budgies out there. 19 a Roger. Of course we can't tell because there's so many people off frequency because they're using illegal radios that... Do you know, I'd be able to tell what he said if he didn't have that stupid echo. $19.19 a Roger. No, we're not going to get one of those. Oh, does that TX light work? It does. I'd have been really miffed if I'd gone to all the trouble putting it back together and the TX light was no good. We've got another Comtron coming in, and he promises me that's got a Duff meter lamp and a Duff TX LED. Oh, we've got a box of matches as well. So we're going to prop it up on a box of matches. The Cook's matches, just as recommended by one of the viewers. So there we go. That's the Maxcom 4E, and we'll do an on-the-air test later on. So thanks for watching.